Find the area, round to the nearest whole number. Now the area formula for a regular polygon is A equals 1/2 lowercase a n s. And the lowercase a is for apothem. N is the number of sides. And s is the side length. So we need to find these three values out, and then we can solve for the area of the regular polygon. Now this is an octagon. And figuring out the apothem, we first need to find out what the measure of the central angle is for one of these triangles. And notice that if you were to draw all these, each one of these segments I'm drawing is called a radius. The radius length is 10. Notice there are 8 triangles. They're all congruent, and they're all isosceles triangles. So let's find out what the measure of one of these central angles is for the triangle. Since there are 8 of them, the angle measure is going to be 360 degrees divided by 8. And that's 45. So we have 45 degrees for that central angle. Now let me draw this triangle a little bit bigger. Draw it over here. So we have 45 degrees right here. Now the apothem is drawn from the center of the shape to the midpoint of one of the sides of the shape. It makes a right angle. And we know we have a 10 here. This is that radius. And this is just a larger version of this triangle up here. So we need to figure out what this is. This is the apothem A. And we can figure it out by using trig ratios. And we need to know this angle here. So we have the larger central angle is 45 degrees. Half of that is going to be 22.5 degrees. So 22.5 degrees is going to be our angle that we use for the trig ratios. Now to solve for A, we're going to be using the cosine ratio because A is adjacent to the 22.5 degrees. So we're going to have the cosine of 22.5 degrees equals the adjacent side, which is A, divided by the hypotenuse, which is 10. So we'll make a proportion here and cross multiply. A equals 10 cosine of 22.5 degrees. So we can figure out the apothem using that trig ratio. So it's going to be 10 times the cosine of 22.5. So 9.238, we'll just round it to 9.2. So the apothem equals 9.2. So that's the first part of the formula. Next we need to know the number of sides. That's pretty easy. There are 8 sides. So n equals 8. Side length, that's going to be one of these guys, or also one of these on a larger triangle. And we can figure that out using a trig ratio. So what I'll do is I'll assign x to be the opposite side of this little right triangle. So we'll have another x here, and these two x's make the side length of the octagon. So we can solve for x and then double it. That'll give you s, which is the side length. So this time we're going to use the sine ratio. We're going to use the x and the 10, and the x is the opposite side from the 22.5 degrees. 10 is the hypotenuse. So sine of 22.5 degrees equals x divided by 10. Make it a proportion and cross multiply to solve. X equals 10 times the sine of 22.5 degrees. So let's see, 10 times the sine of 22.5. It's 3.8. So x equals 3.8. That means s, the side length, equals 2 times 3.8. So that's 7.6. So s equals 7.6. Now we can substitute all the known values that we found into the area formula. So the area equals 1/2 times A, the apothem, which we know is 9.2, times the number of sides, which is 8, times side length S, which is 7.6. Now let's put that in the calculator and see what we get. So I use 0.5 for the 1/2 times 9.2 times 8 times 7.6. 279.68 rounded to the nearest whole number is 280. So the area equals 280, and there aren't any units given, so we're just going to say 280. So let's review the process. Find the central angle, which we found to be 45 degrees. Then we found the apothem, the number of sides, the side length, and then combined it all together.